You're given the probability distribution for a random variable representing the number of hits a baseball player obtained in a game for the 2012 baseball season. Now, this random variable is discrete. We see that we are counting from 0 to 5. And in my way of putting it, there is a smallest distance between two different scores. So the first thing we're asked for is, what is the theoretical mean? And I'm going to show this both on Excel and on the TI-84. Then things afterwards, I will stay with Excel. So let's see here. In list 1, I will be entering the scores. It's not awake yet. There we go. And then the associated probabilities. Make sure I enter these correctly. Okay, there we go. And to get the theoretical mean, we would multiply the scores by their associated probabilities. So I'll go to the top of list 3 and tell it that I'm going to be multiplying list 1. So press second and then 1. Multiply that by what's in list 2. List 2. There we go. Okay. So that is giving us score times probability. We then need the sum of what is in list 3. And we can let the calculator do that for us. Going to stat again, calc submenu for calculate. And then option 1 is short for one variable statistics. List 3. Notice you do not want X bar. The reason for that is that with these probabilities going 4 places, that's the 10,000th place. Then what you would want to do if you were going to try to use X bar is to list 0 1,673 times, 1 3,289 times, etc., so that you have those 10,000 scores of 0s, 1s, 2s, 3s, 4s, and 5s with a lot of repetition. And then you would be using the formula for X bar, where you add up all the scores, including the repetition, and then divide by how many scores. But since we are using score times probability, you're baking in there the repetition and the total number of scores. That's baked into the formula. We need the sum that's on the second row here, and they want that to 3 places, so that's going to round to 1.678. Now I'm also going to open this up in Excel before coming up with a standard deviation. All right, here we go. So on Excel, to tell it to multiply score times probability, type equals, then press on the first entry where there's a score, type the multiplication symbol, press on the press on the first corresponding entry where the probability is for that score, and then on that cell, select it, go to the lower right, drag down, one more row, there we go. And then at the bottom of that, we can type equals sum, First one's in column C, row 2, colon, column C, row 7. And when rounding that result to 3 places, same result. Now for the rest of this, I'm going to use Excel to get the standard deviation, etc. So now what we need is score minus mean, which is the mu sub x, the mean, the theoretical mean of the random variable x, squared times the probability of the score. That's not going to be all that we need to do, but that'll get through a lot of it. There is a second formula, but this one is, I believe, easiest to set up with what we've already done in the table. So score, notice I typed that equal there, minus mean. I'm not taking the rounded version. I wanted to keep going back to row 8 where I have the mean. Square that, multiply by the associated probability. And depending on how exact this needs to be, I can stretch out the column. And I've changed the font as well. Okay, so I'm going to drag this down, get the results for the remainder of the scores, and then get the sum. That gives you the variance of the random variable. We do not need to do any division because, again, the repetition of these scores, if we were to do trials, like 10,000 trials, the probabilities have the repetition and the total number baked in there. So no division needed. Just take the square roots of that previous result. They want it, I think, to 10 place, sorry, the 10th place, so 1 after the decimal point, but let's see here. Nope, 3 decimal places also. Okay, so that's going to round up to 1.242. Then we are asked for the mean of the random variable based on the simulation of 25 games. That shows up here, and I'm going to open up that in Excel. So you could tell it to take the sum of everything from column A, row 1 to column A, 25. But if you just type equals average A1 to A25, by the way, you'd still have to divide that sum by 25, of course. But we just type that, we get the 1.32. And I think they're going to want the standard deviation as well. Yes. Okay, give me just a moment on that. Okay, I believe that we need to use standard deviation stdev.s for sample. And that's from A1 to A25. Let's see if I'm right. That's to 3 places. It's going to round down to 1.069. Okay, good. And then back here again for the simulation for 50 games. That's the second one. I'm going to open that in Excel. So now I have the one with the data from the simulation of 50 games. Tell it to give us the average from A1 to A50 this time. And the standard deviation equals stdev.s, that dot s for sample, A1 to A50. All right, so we've got 1.66 for the mean. It doesn't even go 3 places or more, so no rounding to worry about there. And then for standard deviation, round that to 3 places. That's going to round down to 1.287, down because of the 4 after it. So the simulation of 25 games, the mean is, let's see, no, I'm not trying to select something here. I just press it and then go back so that I can read the results. We had a theoretical mean of 1.678. For the 25 games, it was lower. And yet it's not all that far away. It's between 1 and 2. And then for the 50 games, it was between 1 and 2, just like the theoretical mean. It's between 1 and 2. So I believe they're looking for about the same as the theoretical mean and the standard deviation. I think they might want the same. Probably want that all the way through. And this is particularly with the mean for what we've covered so far. Looks like we're talking about how with more and more trials, you're going to get close and stay close to eventually the theoretical mean. All right.